So, here's the headline you've probably seen floating around. NASA wants to put nukes on the moon. It sounds wild, maybe even a little terrifying. Like, really? Humanity finally decides to go back to the moon, and the first thing we pack is a nuclear reactor? Why nukes? Let's start with the basics. NASA is working on a plan to deliver a compact nuclear fission reactor to the moon. Not some giant power plant with smokestacks. Think of it as a small, rugged box, something that can crank out about 100 kilowatts of power. Now, you might ask, is that a lot? Not really. Your average hairdryer pulls about 1,000 watts. Do the math, 100 kilowatts is basically the energy to run 100 hairdryers at once. Hardly enough to power New York City, but it's more than enough to keep a small lunar outpost alive and kicking. So the nuclear device isn't about making the moon into a second Las Vegas Strip. It's about survival. Because living on the moon isn't like setting up camp in your backyard. The moon is brutal. Temperatures swing from plus 200 degree Fahrenheit in the daytime to 200 degree Fahrenheit at night. No atmosphere to even things out. No clouds to soften the sunlight. No blanket of air to hold the heat at night. Just extremes. And here's the kicker. A single day on the moon lasts an entire month on Earth. That means 2 weeks of constant sunlight, followed by 2 weeks of total darkness. So sure, you could put up solar panels. They work beautifully during those 2 weeks of sunshine. But then comes the 2-week night. Suddenly, you're in the dark, and your batteries are freezing solid at hundreds of degrees below zero. That's why nuclear looks attractive. A fission reactor doesn't care if the sun's up or down. It just hums along, providing steady power to keep the lights on, the heaters running, and the science experiments alive. Now, this is all part of a much bigger plan. NASA's Artemis program is the sequel to Apollo. The goal isn't just to plant a flag and head home, it's to build a sustainable lunar presence. Here's the roadmap. Artemis 1 already happened. An uncrewed test flight around the moon. Artemis 2 is next astronauts aboard, but they won't land. They'll orbit and return. Artemis 3 is the big one. Humans back on the lunar surface. And after that, the missions keep building Artemis 4, V, VI, each one laying the groundwork for a base, a permanent foothold. Where? Most likely at the moon's south pole. Why the South Pole? Because in those permanently shadowed craters, sunlight never reaches the bottom. They're cold traps. And over billions of years, comets have smacked into the moon, leaving behind precious water ice in those frozen basins. That water could be mined, some of it for drinking, some of it split into hydrogen and oxygen, the ingredients of rocket fuel. In other words, the moon could supply not just life support, but also the fuel for return trips, or even deeper missions into the solar system. NASA calls this in situ resource utilization, using what's already there. And it's the only way permanent settlements will ever make sense off Earth. So far, that's the science. But here's where it gets political. Because the truth is, the US doesn't just wake up one day and decide, hey, let's go back to the moon. The space race has always been about competition. The original Apollo missions, they weren't driven by pure exploration. They were driven by the Cold War. The US had to prove it was better, faster, smarter than the Soviet Union. The moon landing was a statement to the world. We're number one. Now, fast forward to today. Who's on our radar? China. China has openly announced plans to put taikonauts, their astronauts, on the moon. And in Washington, that raised eyebrows. Suddenly, it's déjà vu. Another rival, another race, another reason to accelerate. That's why Congress gave NASA the green light to move faster on Artemis, to put a base on the moon, and yes, to explore nuclear reactors as a long-term power source. Because in geopolitics, beating China to the moon means bragging rights. Now, you might hear the word nuclear and instantly picture mushroom clouds. But that's not what we're talking about here. This is nuclear fission in a compact, sealed system. And nuclear power isn't some alien concept. In France, for example, about 2/3 of their electricity comes from nuclear plants. They've been doing this for decades, safely, to the point that they actually export billions of euros of surplus energy every year. So the fear of nukes often comes from outdated ideas of Cold War weapons. In reality, it's about careful engineering and design. And yes, there are risks. The moon's surface is littered with craters, proof that it gets smacked by space rocks. What if a meteorite hits the reactor? Well, if that happens, you've probably got bigger problems than the reactor. But still, engineers are thinking ahead. The plan? Bury it, shield it, keep it safe underground. Now, here's something worth clearing up. You'll sometimes hear people say, we need a moon base so we can launch missions to Mars. Sounds logical, right? Stop at the moon, then keep going to Mars. But in practice, it doesn't really work that way. Landing on the moon requires fuel. Taking off again requires more fuel. So if Mars is your destination, the moon doesn't actually make the journey easier. In fact, it could make it harder. If you want to go to Mars, you're better off going directly to Mars. That said, the moon is still a great test bed. You can practice building habitats, mining resources, and surviving long stays away from Earth. And you can pre-position supplies. Imagine sending uncrewed cargo ships ahead of the astronauts. Food, equipment, spare parts, all waiting when the crew arrives. That's where the moon makes sense, as a training ground for deep space. So let's zoom out. Why is this happening now? Why push nuclear power on the moon today? The answer is part technology, part politics. On the tech side, we're finally at a point where we can design small, rugged reactors that could actually work in the harsh lunar environment. On the political side, it's about competition with China, with Russia, with whoever wants to claim first in the new space race. But there's also a danger. When politics drives science, the timeline gets compressed. Risks get overlooked. Billions of taxpayer dollars can be spent chasing bragging rights instead of carefully planned progress. That's why some critics warn, yes, nuclear power on the moon makes sense, but rushing it to beat another country could be reckless. And this raises a bigger question. We know science funding is shaped by politics. Always has been. The space race, the Manhattan Project, the Human Genome Project, all were steered by geopolitical agendas. But what do we lose when science becomes a pawn? What research doesn't get funded? What breakthroughs never happen because resources were shifted to the latest political headline? It's something worth thinking about. Still, if the Artemis program succeeds, the moon won't just be a flag and footprints destination anymore. It'll be a base, a lab, a fuel depot, maybe even a new home for humanity. Picture it. Astronauts mining water ice in shadowed craters, splitting it into hydrogen and oxygen, refueling rockets for return trips, printing tools and structures out of lunar soil with 3D printers, a nuclear reactor humming away underground, keeping the lights on. It's not science fiction anymore. It's a roadmap. And if NASA hits its targets, it could all be happening before 2030. So when you see headlines about nukes on the moon, remember, this isn't about weapons. It's about energy. It's about survival. And yes, it's about politics. The moon has always been a mirror of Earth's ambitions. In the 1962nd, it was about proving who was stronger. Today, it's about proving who's leading the future. But underneath the competition, there's still wonder. Because for all the politics, for all the technology, what we're really doing is learning how to live beyond Earth. And that's the first step in becoming a truly spacefaring civilization. So keep an eye on the Artemis missions. Because the next time you look up at the moon, it might not just be reflecting sunlight. It might be reflecting humanity's next great leap.